If the spring constant of a simple harmonic oscillator is doubled, by what factor will the mass of the system need to change in order for the frequency of the motion to remain the same? Alright, so we are given K2 in terms of K1. 2 times K1, doubled. And the frequency is supposed to remain the same. So for the frequency to remain the same, by what factor must M1 multiplied is a question asked. So M2 is going to be equal to NM1. And we are asked to find out the factor N. Alright, we are told that the frequency is going to be the same. So if you have a spring like this one, mass right here, this is K1. And the second spring has a different constant that's related to K1, and that is K2, where K2 is equal to twice K1. By what factor should we multiply M in order to find the mass? So I have M2 here. For the frequency to remain the same, F1 has to be equal to F2, and that means 1 over 2 pi multiplied by the square root of K1 over M1 must be equal to 1 over 2 pi multiplied by the square root of K2 over M2. Alright, so we can multiply both sides by 2 pi so that we can get rid of 1 over 2 pi. We can square both sides. Therefore, we have K1 over M1 is equal to K2. So instead of K2 this time, we can write 2K1. Just substitute K2 by 2K1. It's a given information. And M2 by M1. So K1 goes with K1. M1 goes with M1. So 1 is equal to 2 over N. Therefore, N is equal to 2. So if the spring constant is doubled, for the frequency to remain the same, the mass has to be doubled.